Hello everyone, in this video we're going to go over the indolamine synthesis pathway. So the indolamines in general are just going to be serotonin and melatonin. So the molecule we start with is going to be tryptophan. That's the precursor to all of these. So tryptophan is going to look like this. And tryptophan is going to be transformed in this step by an enzyme called tryptophan hydroxylase. Which is abbreviated as TPH. You don't want to do TH because that would be confused with tyrosine hydroxylase, which is in the catecholamine pathway. So when we transform this molecule using that enzyme, we get a similar looking molecule, with the difference being that we just add a hydroxyl group to this carbon. This is called, this molecule here, it's called 5-hydroxy tryptophan. Also called 5-HTP. You might see that. Then it is going to react with an enzyme called aromatic L-amino acid decarboxylase. This enzyme is also known as just AAD. And this enzyme is going to take the molecule, and I need to fix a few things. So first of all, the hydroxyl group is still there. There should be a hydrogen here. Since it's a decarboxylase enzyme, it's going to basically take off a carboxyl group. So the carboxyl group is over here, so that's going to go away. This is going to detach. We're going to replace that with a hydrogen. So there's an extra hydrogen on this carbon. And this molecule that we have, that's this new molecule, is serotonin, also known as 5-hydroxy tryptamine, right, or 5-HTP, or 5-HT really, 5-HT, which is serotonin. So this is the very well-known neuromodulator, serotonin. Now, this is going to react with another enzyme. I want to find the full name of it. So we're going to have an enzyme called arylylamine and acetyl transferase, also just known as AANAT. And what this is going to do is modify this molecule. So we're going to have going to take a hydrogen off of this carbon, add an oxygen, and then add a CH3 methyl group. So now this molecule is the molecule after serotonin. It's going to be called N-acetyl serotonin. So we really added an acetyl group. And it's next to the nitrogen group, so it's N-acetyl serotonin for that reason. I've just realized this is not right. Turns out that this acetyl group attaches directly to the nitrogen, so it's actually looks more like that. The next enzyme is going to be called acetyl serotonin O-methyltransferase. Or ASMT. When we use this enzyme, we're going to take the same molecule and do not enjoy the weird things coming on here. We're going to take this group and then replace it with this. And this molecule here is melatonin. Okay, so that's the whole pathway. So to go over what happened overall, we begin with tryptophan and we use TPH to add a hydroxyl group on carbon 5 of the benzene ring, or just the aromatic ring, we should say. Then we used AAD and took off a carboxyl group, so that's no longer there here, and that yielded serotonin. And then we took serotonin, used the AANAT enzyme, added an acetyl group to the nitrogen. So as opposed to the nitrogen having two hydrogens around it, it now has a hydrogen and an acetyl group. And then adding basically replacing this hydrogen with a methyl using ASMT, we made melatonin. So that's the entire pathway, and I hope you learned how that works.